The described installation where a 10 kilowatt generator with a 50 amp breaker is backing up a 200 amp panel via a 200 amp automatic transfer switch is not an acceptable practice. The generator should be sized to match the ampacity of the panel that it is intended to back up. In the described scenario, the generator should be capable of providing close to 200 amps. A generator that is significantly undersized compared to the panel it is backing up is unable to provide sufficient power to operate the electrical loads within the house. This can result in several potential issues. Firstly, the system may experience brownouts, which occur when the voltage drops below the normal operating range. This can damage sensitive electronic equipment and cause lights to dim. Secondly, blackouts are possible where the generator is simply unable to supply enough power to keep the essential circuits running and the system shuts down completely, or the breaker trips due to an overcurrent. Thirdly, an undersized generator is subject to undue strain, which can dramatically shorten its lifespan and lead to premature failure. Fourthly, the generator may not be able to start certain appliances or equipment with high starting currents, such as air conditioners or refrigerators. When selecting a generator for a backup system, properly sizing the generator to the panel it is backing up is vital. This ensures the generator can adequately power the necessary electrical devices during an outage without being overloaded or damaged. To properly size a generator, firstly determine the total wattage of all of the appliances and devices that need to be powered simultaneously during a power outage. This includes essential loads such as lighting, refrigeration, heating or cooling systems, medical equipment, and critical electronic devices. Secondly, consider the starting watts of certain appliances. Some appliances, particularly those with motors like air conditioners, refrigerators, and pumps, require a higher surge of power to start up than they do to run continuously. This starting wattage needs to be factored into the total generator size calculation. Thirdly, add the running watts of all the continuous loads to the largest starting wattage of any single appliance. This will give a conservative estimate of the total wattage the generator needs to supply. Fourthly, divide the total wattage by the voltage of the electrical system. For a standard residential 120 volts or 240 volt system, this calculation will yield the required amperage. Fifthly, choose a generator that is rated for at least the calculated amperage. It is generally recommended to choose a generator with a slightly higher amperage rating than what is calculated to provide a safety margin and accommodate any future increases in electrical load. Sixthly, ensure the generator is equipped with an appropriate transfer switch. An automatic transfer switch is recommended to automatically switch the electrical supply from the utility grid to the generator during a power outage and back again when the utility power is restored. The transfer switch should be rated for the same amperage as the electrical panel. Seventhly, comply with all applicable electrical codes and regulations. Generator installations must comply with the National Electrical Code and any local codes or regulations. Consult with a qualified electrician to ensure the installation is safe and compliant. Eighthly, consider the fuel source and run time of the generator. Generators can be powered by gasoline, propane, or natural gas. Each fuel source has its advantages and disadvantages in terms of cost, availability, and run time. Choose a fuel source that is readily available and provides sufficient run time for the anticipated duration of power outages. Ninthly, maintain the generator properly. Regular maintenance, including oil changes, filter replacements, and spark plug replacements, is essential to ensure the generator operates reliably and efficiently. Tenthly, test the generator regularly. Periodically test the generator under load to ensure it is functioning properly and can provide the necessary power during an outage. Here is a more detailed breakdown of the aspects mentioned. When determining the wattage requirements of the devices, it is important to look at the nameplate on each appliance or device to determine its running wattage. This is the amount of power the device consumes while it is operating continuously. For devices with motors, also note the starting wattage, which is typically higher than the running wattage. To calculate the total wattage, use a spreadsheet or calculator to add up the running wattages of all the continuous loads and the largest starting wattage of any single motor-driven appliance. This will provide a conservative estimate of the total power demand during an outage. When selecting a generator, it is better to err on the side of caution and choose a model with a slightly higher wattage rating than the calculated demand. This will provide a buffer for any unexpected increases in load or temporary surges in power demand. Additionally, a generator that is running at less than its maximum capacity will typically operate more efficiently and last longer. The automatic transfer switch plays a vital role in a backup generator system. It is responsible for safely disconnecting the electrical system from the utility grid and connecting it to the generator when a power outage occurs. This prevents backfeed, which is a dangerous condition where power from the generator flows back into the utility grid, potentially endangering utility workers and damaging equipment. The transfer switch should be rated for the same amperage as the main electrical panel to ensure it can handle the full load of the electrical system. It should also be installed by a qualified electrician in accordance with all applicable codes and regulations. Regarding fuel sources, gasoline generators are the most common type and are typically less expensive than propane or natural gas models. However, gasoline has a limited shelf life and can become stale over time, making it difficult to start the generator. Propane generators are more expensive but offer a longer shelf life and cleaner burning operation. Natural gas generators are the most expensive but can be connected directly to a natural gas line, eliminating the need to store fuel. The choice of fuel source depends on the specific needs and preferences. Regular maintenance is crucial for ensuring the reliable operation of a generator. This includes checking the oil level regularly and changing the oil according to the manufacturer's recommendations. It also includes cleaning or replacing the air filter, checking the spark plugs, and inspecting the fuel lines for any leaks or damage. Proper maintenance will help to prolong the life of the generator and ensure it is ready to provide power when needed. Periodic testing of the generator under load is also important. This involves starting the generator and running it with a load that simulates the typical power demand during an outage. This will verify that the generator is functioning properly and can provide the necessary power to keep essential appliances and devices running. It will also identify any potential problems that need to be addressed before an actual power outage occurs. Consider an example calculation. Suppose that during a power outage you need to power the following appliances: lighting totaling 500 watts, a refrigerator with 600 running watts and 1800 starting watts, a furnace fan with 800 running watts, and a sump pump with 1000 running watts. The total running wattage is 500 watts plus 600 watts plus 800 watts plus 1000 watts, which equals 2900 watts. The largest starting wattage is 1800 watts for the refrigerator. Therefore, the total wattage that the generator needs to supply is 2900 watts plus 1800 watts, which equals 4700 watts. If the electrical system is 240 volts, then the required amperage is 4700 watts divided by 240 volts, which equals approximately 19.6 amps. Therefore, you would need to choose a generator that is rated for at least 20 amps or higher to provide sufficient power during a power outage. The National Electrical Code, also known as NEC, provides comprehensive guidelines for the safe installation of electrical systems, including backup generators. It is important to consult the NEC and any local codes or regulations to ensure that the generator installation is compliant and safe. Some key NEC requirements for generator installations include proper grounding, overcurrent protection, wiring methods, and transfer switch requirements. A qualified electrician can ensure that the generator installation meets all applicable code requirements. In summary, properly sizing a generator for a backup system is crucial for ensuring reliable power during an outage and preventing damage to the generator and electrical system. This involves calculating the total wattage requirements, selecting a generator with an appropriate amperage rating, installing an automatic transfer switch, complying with all applicable codes and regulations, and performing regular maintenance and testing. By following these guidelines, you can ensure that the backup generator system provides safe and reliable power when needed. Ignoring these crucial steps may result in severe consequences, including fire, injuries, or even death. Therefore, it is crucial to seek the expertise of qualified professionals and adhere to safety guidelines to minimize the risks associated with generator systems. In addition to the technical aspects, it is equally important to educate yourself and your family about the safe operation of generators. Understanding the potential hazards such as carbon monoxide poisoning and taking preventive measures can help avoid accidents and ensure the well-being of everyone in the household. Remember, generators are powerful machines that require respect and caution. When handled responsibly and maintained diligently, they can provide a valuable source of backup power during emergencies.